Did you know that the mass of helium is less than the mass of its constituent particles? Hi, I'm a nuclear technical chemist. I've worked in nuclear for the past 5 years, and I am going to explain to you the physics of fission and fusion. Yes, it is true, and it all has to do with binding energy and mass defect. So you might ask, what is mass defect? Well, it's pretty simple. Mass defect is the difference in atomic mass between the bound state and the unbound state. And we're not really concerned with the electrons here because they are so tiny in comparison to the bound state. The relative weight of an electron to a nucleon is about 1 in 1836. That's the fractional value, approximately. So when two nucleons come together and form a more tightly bound system, energy is released. Only up to a certain point, though. Because of the electrostatic forces working within a nucleus, only up to a certain point will a nucleus get more tightly bound the more nucleons add. So once you get past iron, you're actually going to get less tightly bound the more nucleons you add to the nucleus. And so, if you know anything about astronomy, this is why stars have cores of iron. It's because up until this point, they are not expending energy to undergo the fusion process. So fission is the opposite of this process. You have a neutron that will be absorbed into a heavy atom like uranium-235. Under the liquid drop model, that uranium will form out into lobes, and then those lobes will have electrostatic forces that push against each other strongly, and this will tear the atom apart, and then you will have two heavy fission products which are unstable and radioactive. You will have neutrons, neutrinos, electrons that come out. But the thing is, it's the same amount of nucleons. There's no loss of conservation of the number of nucleons or electrons or charge. The only conversion is from mass. The bound state of the uranium-235 was less tightly bound, so you had more mass here, and then it becomes more tightly bound in the second arrangement, and so there is less total mass. And so this is the difference between fusion and fission, and you can see why scientists have been looking for an answer to fusion for so long, because at the beginning of this binding energy per nucleon curve, there seems to be such a quick increase. The binding energy seems to be much more efficient than it is for uranium-235, which also has radioactive byproducts, which we have become effective at dealing with, but it's still something that you have to deal with.